Welcome to the evolution study section. Here we break down how different training choices impacted performance on DINOv2. So let's start with recipe upgrade payoff. So first is taking 11 training tweaks on the top of the iBoard baseline gave a big toast here. On ImageNet 1K KNN accuracy performance jumped from 72.9 to 82. That's a 9-point gain. The biggest contributor were the Coliolos, which added plus 2.3 points and increases batch size which gives a plus 1.2. This shows how small technical adjustment can significantly add up when combined. So next point is clean data beats quantity alone. So data quantity matters more than the quantity. The VITG model trained on the curated LVD 142M dataset performed better than the same model trained on the 142 million uncurated web images on the Oxford M dataset. The curated version improved map by plus 10 points, so better data gives better results as we all know. So sorry, I move forward. So next point is loss roles are distinct. Different loss functions serve different purposes. The Colio regularized improved retrieval performance by plus 8 map on Oxford map. Meanwhile, the iBot map patch sizes loss improved segmentation on ADE 20K by plus 3 MIOU. Both losses bring value but for different type of task. So now it's time to move on next slide. So bigger model loves bigger model is the next point here. So as model increases, so does the need for large and rich data increases. Larger models like VITG benefited significantly from the LVD 142M dataset compared to the ImageNet 22K. So this tells to unlock the potential of higher architectures as also need bigger and cleaner dataset. Okay, so next point is distillation is free gain. So distillation turned out to be a huge win. A smaller VITL model distilled from a VITG outperformed the same model trained from scratch across all 12 benchmarks. This means we can get the performance of large model in smaller, faster model for free compute wise. So next slide is so here is the table. So in this table, this is a iBot versus DINOv2 tweak table. So here is a layer by layer view. Each row shows a tweak added to the iBot baseline. Column, warm-up schedules, batch size, all contributed meaningful gains are here. Some changes like layer scale, reduced linear accuracy but perform training stability, showing a trade-off. The final DINOv2 model combines the best of these for optimal results. So it's all about this table. So next here is also table number 2 from the evolution study section. So this is a table for evaluation of the source of pre-training data. So the table compares performance across dataset. LVD 142 outperformed uncurated data across all benchmarks and was competitive with ImageNet 22K, even better on several tasks. Carefully curated diverse data leads to better, more general visual features. So it's all about this table. So now we move forward. So this is a figure uh, which shows the model scale versus data scale. So this figure shows how scaling models with high quality data matters across benchmarks like cars, food 101 and Oxford H. VITG model trained on LVD 142M consistently beat the same model trained on ImageNet 22K. More data, better models gives better results, as we already know that. So it's all about this figure. So next we move forward. So here we discuss about colio and MIM loss effects. So here we isolate the effect of colio and MIM losses. Removing colio drops Oxford M retrieval map from 63.9 to 55.6. Removing MIM reduced segmentation MIOU by nearly 3 points. Together, these ablution confirms that both losses are essential for different type of tasks. So we will discuss in next slide here in summarized way. To sum up colio loss, improve retrieval, MIM improves segmentation, and each training change contribute differently. All models were trained for equal steps, and results uses simple linear props, showing the direct effect of each component clearly. So, here we can see effectiveness of knowledge distillation. So this is a radar chart that shows performance across 12 benchmarks. The VITL distilled from VITG consistently outperforms the same VITL trained from scratch. Sometimes even surprising the teacher, distillation makes models both smaller and smarter. It's all about this figure. So next, this is the here is the role of resolution. So role of resolution, but training cost is high. So model trained entirely at 416 pixel to do best, but training first at 224 and finishing at 416 give similar performance at for lower cost. That's why DINOv2 includes a short high res finisher stage at the end here. So let's now I can summarize the whole ablation study in few points. So ablation study in DINOv2 teaches a lot: better recipes, clean data, task specific losses, and model scalings, efficient training tricks. And it also teaches knowledge distillation. All play key roles. Combined, they enable DINOv2 to deliver state-of-the-art, self-surprised performance across image pixel and instance level tasks. So it's all about the ablation study parts. So thank you.